Hello students, good evening to all of you all. Assalamu alaikum. Welcome to the online session. I hope you all can hear me clearly and see the screen clearly. Yeah, if any of your friends are missing, quickly inform them to come and join because this is actually a open session. So they can join. I'll share the link. I have already shared the link in WhatsApp. Yeah, many of you all are having the term test. You know, the ones who are having science tomorrow, it will be beneficial. But the ones who are having some other subjects tomorrow, yeah, at least you all can stay for 1 hour. Today I won't drag that much because many students send me a request saying that they're having exams, non-science related exam today. So anyways, so last week we completed the MCQ part. We discussed very few questions, but we discussed it in a deep, detailed way so that we were able to clear the doubts related to that theory session. That means the theory related to that question, the doubts related to that, what are the other answers referring to, all that we have discussed. Yeah, so this is just a sample of the second paper. Normally for your O level, the front page of your O level part 2 paper. So 34 is the number, subject number, science is 34, E is English medium, 2 means part 2. General certificate of examination, December 2019. So I think that was the last paper which was done on time. From there onwards, COVID-19 started. 2020, 21, 22, all that the paper was delayed. It was not held in December. So this was the last December paper 2019, Science 2. And here you can see the date, 7th of December. It was a Saturday. Normally they keep on Saturdays. Science paper used to be on Saturdays. Last year it was Friday. But normally it used to be on Saturdays. So this is the timing 8:30 to 11:40. That means 10 minutes extra reading time is given. 8:30, 9:30, 10:30, 11:30. 3 hours plus 10 minutes extra reading time. Use additional reading time to go through the question paper, select the question and decide on the question that you give priority in answering. Because this has two parts. Part A and Part B. Part A, there are 4 compulsory questions. Part B, there are totally 5 questions. Out of that, you can answer 3. Last week, I have discussed the ones who are not there. Please go through it. Please go through the recording, then you will get a clear idea. Here, you have to write the index number clearly because you are going to hand over this paper because this is going to be the structured essays first page. No, so you have to return this paper to the invigilator. So you have to write the index number clearly and properly. Write your answers in neat handwriting. That is one important instruction. Answer 4 questions from part A in the space provided. Of the 5 questions in B, answer 3 questions only. After answering, type part A and the answer script of part B together and hand over. So once you start the past papers next year, the current grade 10 students, once you are promoted to grade 11, and by the end of first term, we will be starting the past papers. So at that time, you will understand how the questions are. Now we are going to do unit papers, model papers. So where can I get the recording of the classes? Is it available in the website? Putha, in my YouTube channel, it is available. You all can type Science Academy Colombo. Or if you put Rihan Rahim Science, my videos will be there. In that, you will be able to get my channel and you can subscribe and then you all can watch the recording. And also I have put it in the groups. Okay, so the WhatsApp group is very easier. So whatever links, YouTube links and all the Zoom links I have put to the WhatsApp group. So in future, when you start your grade 11, you will be starting past papers. At that time, you will be doing real O-level questions. So I just gave you the idea. Last week, I gave the front view of the part 1 paper. Now front view of the part 2 paper. So let's go for the discussion. Questions related to motion in straight line, forces and friction. As much as possible, Within 1 hour, we'll try to cover as much as possible, because today I'm hoping to stop a little bit early so that you will be able to, do the school revision, because many schools, they are having exams tomorrow. So let's quickly go into the questions. Which of the following graph represents an object which is stationary? That means object is not moving. So if the object is not moving, we can draw three types of graphs. Normally in our syllabus, we have distance time graph, velocity time graph, acceleration time graph. These are the three possible graphs. Out of that, for an object which is stationary, we can't get acceleration time graph, because how can a object which is staying in one place have acceleration? It doesn't have even a velocity or speed, so this VT graph is also not applicable. DT graph, there are two possibilities. If the object has not moved at all, listen to this carefully. If the object has not moved at all, then the graph will be a zero graph. But let's say this is coming in the middle portion of a question where the object has moved and then stopped. Then the graph will grow like this after moving for some time and stop. So that's it. Here we don't have a zero graph situation, no? So we can go for this situation. Okay, so remember, stationary objects have two situations. One is not even started the motion. Second situation, here I am putting it as B. It has started and then traveled some distance and then stopped. From there, we are plotting the graph. So here, according to this A and B, here they have represents the B concept. So distance, time graph, this is correct. Here, sometimes you might get confused. This is all the same thing. No, this graph is totally different. This is a velocity time graph. I hope you all are clear. The papers which I am sending, okay, the papers which I am doing it, it's already there in the group. The ones who are not there in the group, please send me a message, WhatsApp message with your name, grade, and school. This is my WhatsApp number. 828366. So I hope you all are clear. And here, distance time graph is increasing. That means object is moving. That is represented by this graph. No acceleration, just moving with the same velocity, that is represented like this. I have a YouTube video. We did a seminar related to all the 12 graphs present in our syllabus. So the ones who are not familiar with the graph part, please go and watch that recording. It will be there in our YouTube channel. You all will understand all the 12 graphs and questions related to these graphs. All have been discussed. Please watch it. It's totally free. Before your exam, somehow watch it. Second one, which of the following graph represents a fruit falling from a tree? Fruit falling from a tree. So when a fruit is falling down from a tree, remember Buddha, now let's say normally we consider it as from the topmost branch only it is falling down. So when starting to fall down, naturally it falls down now. So the initial velocity will be 0. Initial velocity will be 0. Then when coming down, due to gravitational acceleration, the fruit is also coming down, gravity is also pulling the object downwards. So due to the gravitational force and due to the gravitational acceleration, velocity will increase. It's an accelerating object. When anything is falling down, it is an acceleration situation. When something is thrown up, it is a deceleration situation. And final velocity will be maximum. So Buddha, they are asking you the graph. All the graphs are velocity time graph. So no problem. At the starting stage, now for example, I'll say this took 5 seconds to reach the ground. At 0 second, the velocity was 0. Then little by little, the velocity increases. And by the end of 5 seconds, what will be the velocity? I am just giving you all a value of 5 seconds scalar. By the end of 5 seconds, what will be the speed of the fruit? For that, we have an equation v equals u plus at. V equals u plus at. So don't think this is a new equation. This is a equation derived from your acceleration equation. So you didn't upload today's paper in the group. No, Puta, we are doing the last week's paper. Continuation of the last week paper because we were unable to complete it. No. So final velocity equals initial velocity 0 plus acceleration is gravitational acceleration 10, time is so 50. This is the graph. So first one is the most suitable graph. Many of you all thought this one, but wrong. Because here what is happening? Higher velocity, it is reducing. Object falling down, this can be okay. Sorry, object thrown up. Object thrown up, this graph is correct. But object falling down. Yeah, the Azan is going on. Give me 1 minute. So until that, can you all find the height of the plant? Yeah, good. Some have sent me the answer. Today I'll give you all a short form also for that. Wait, quickly I'll send the PDF again in the group. New students have joined the group. Okay. So, Putha, we are doing the continuation of last week. We are doing the motion related question. So, in this equation, we some students don't know this equation. V equals U plus AT. Actually, Putha, it's nothing new to you all. Wait, I'll explain to you clearly. Because it seems like in schools they have not given the equations properly. You all know the acceleration equation. Acceleration equals final velocity minus initial velocity over time. You all know this, right? So, therefore, we are modifying it and making V the subject. So, when you are making V the subject, you will get an equation V equals U plus AT. So, if the object is falling down from a tree, sorry, a fruit is falling down from a tree, initial velocity will be zero, no? Anything which is naturally dropped or falling down without pushing it downwards, without throwing it downwards, you are just dropping it. Initial velocity will be zero, final velocity will be the maximum. We have to find the final velocity. For that only we use this equation. So that's why I put V equals initial velocity 0 plus acceleration is 10. How do I know acceleration is 10? Because any falling object, gravitational acceleration is the acceleration. It is 10 ms minus 2. Okay. Into time. So here just I modified the question and I said it takes 5 seconds to come down. So into 5. So final velocity is 50 ms minus 1. So then we are able to draw a complete graph, no? Velocity time graph starting from 0, ending at 50 in the velocity side. In the time side, starting at 0, ending at 5 seconds. This is the graph. Then I modified the question some more and I told you find the height of the plant. Okay, there are 3 methods. First method is school teacher's method. They like to have an equation. I'm not that much satisfied with that method, but I'll just tell you. School teacher method is find the mean velocity or the average velocity and multiply by the time. So to find the mean velocity, what they do is they take the initial velocity plus the final velocity, divide by 2 into the time. This is how they find the mean velocity and then multiply by the time. So you can do it in that method. 50 plus 0 divide by 2 into 5. 50 plus 0 is 50. 50 divided by 2 is 25. 25 into 5 is 125 meters. The height of the plant is 125 meters. The method which I like to approach is graph method. Okay, graph method. Area under the velocity time graph will give you the total distance. So here this is a what shape graph? Triangle. I am using the triangle equation according to maths, half into base into height. Half is half, base is 5, height is 50. 50 into 5 is 250, 250 divided by 2 is 125 meters. So both the methods, we are getting the same answer. Okay. Here we are taking mean velocity into time and getting the answer. Here we are taking the area under the graph. Okay, then for a MCQ question, should we struggle so much? Should we waste our time drawing the graph? Okay, for the MCQ, I'll give a short method. That when I was going through YouTube, I found out a method. Okay, if the object is just dropped, not thrown, okay? If the object is dropped or a fruit is naturally falling. So only for naturally falling or dropped situation, to find the height, I'll give you all a shortest equation. 5 into t squared. 5t squared. 5t squared. For any situation, any falling down situation, you can use this. Shall we try this and see? height of the plant, or if they say it's a building or whatever, height is equal to 5 into t squared. In this situation, I told you t is 5 seconds, 5 squared is 25, 25 into 5 is 125 meters. So use this only for MCQ. This is not a valid equation in your syllabus. This is a shortcut. I hope you all are clear about it. Okay, let's move to the next question. Now, just two questions, but from the second question, see, we have discussed about the school teachers method, the area under the graph method, and a new shortcut method. Okay, then let's move to the next one. Third question, which of the following graph represents an object thrown down from a building? This is a good question. Thrown down from a building, not dropped down. Okay, you're throwing something from up to down, you're throwing it. So in this situation, Buddha, initial velocity will not be zero because you are throwing it. So initial velocity, there will be a value. For example, I can say started with 10 ms minus 1. From there onwards, what will happen to the velocity? It will increase. It will become 20, 30, 40, 50, 60, 70, 80. Until it reaches the ground, velocity will increase. So velocity will be maximum when the object touches the ground. But here the special thing is it is being thrown down, therefore initial velocity is present. So the graph will not start from the zero. Graph will start above the zero. In the velocity side, graph will not start from zero. It will start from somewhere here and then go like this increase. Are you clear about this? So second one is the answer for this. If you all have any doubts, please ask. So as a summary, we can do something like this. Objects drop down or fruit falling from a tree. So all that happens naturally, no? The distance time graph will be, distance increases, no? Sorry, distance time graph will be a curved graph, no? Because it's an acceleration situation. Distance time graph will be something like this curve. Velocity time graph will be starting from zero, it will increase. But for objects thrown down, distance time graph will be a curved graph. Velocity time graph will not start from zero because it is thrown down. It will start from a value and go up like this. Just the ones who don't know, quickly take a screenshot. Yeah, the distance time graph, Buddha, in an acceleration situation, always acceleration situation, no, when object is falling down, it is accelerating towards the ground. In that acceleration situation, distance will be a curved graph. Okay, there is a YouTube video which I have put very simply. I'm showing you all how to draw the graph. Please watch that before the term test, watch it. The heading of that video will be graphs related to grade 10. Graph questions or something like that. Okay, don't worry. I will put the link in the group. Today night, I will put the link in the group. Hari, shall we move on? Take a screenshot. Fourth one, which of the following factor will not change the momentum of an object? So you all know the equation. So will I be able to understand this whole lesson by looking at that video? Graph part, you will be able to understand clearly. Graph part. So momentum, you all know the equation P equals mv. P is momentum, m is the mass of the object, v is the velocity. So when mass increases, momentum increases. When velocity increases, momentum increases. Both mass and velocity increases, mass is also increasing, velocity is also increasing, then momentum will increase very high. Distance is totally not related to the momentum. Okay, so very simple answer. This is not there in the momentum equation. Therefore, this is not related to momentum. What is the unit of momentum? Very simple. Huh? Don't need to memorize. Put the equation. Memorize the equation. P equals mv. Then what is the unit of m? Kg, kilograms. M is mass. V is velocity. ms minus 1. This is the unit of momentum. Kg ms minus 1. The SI unit is also kg ms minus 1. There is something called the fundamental unit. In your syllabus, the fundamental unit word is not there at all. But in a past paper, they have given. So, like, there are some students, they think if you study the textbook, everything is okay. But there are few things which comes beyond the textbook also. So that's why you have to discuss the past papers. So don't worry. Once you all come to grade 11, from the first term itself, we will start past papers. So you don't need to worry about that. And someone was asking me for the revision. Last week, yesterday we had our theory class and I dedicated that full theory class for full revision of the first term for the exam. So today again we can't do that. That's why I'm doing the paper. Okay. So in the theory class yesterday we did the full revision, and next week in our theory, I just want to inform you. Next week we are starting second term in our online theory class. Even in physical, physical, online, everything we are starting theory. Within this week you will get a new tube. Okay. Then fifth one, which of the following VT graph corresponds to the given DT graph? This is a hard question. How to do this? Okay. So for that, Putha, I'll just tell you the connection between a DT graph and a VT graph. Distance time graph and velocity time graph has a connection. Distance time graph's gradient only will give you the velocity value. Gradient. So, Putha, if there is a distance time graph, which is like this 0, velocity time graph also 0. Or there can be a situation where distance time graph is like this, then also velocity is 0. This is object at rest situation. Then let's talk about a situation where object is moving with constant velocity, constant speed, moving with the same speed, object moving with the same speed. DT graph, VT graph. When the object is moving with the same speed, velocity graph will be like this. Distance time graph will be like this. Then the next two situations are increasing velocity. In other words, we call it acceleration. And the other one is decreasing velocity. We call it deceleration. We are going to draw two graphs each. Distance time graph, velocity time graph. Distance time graph, velocity time graph. Acceleration situation, velocity will be increasing. Distance also will be increasing, but curve graph. Then velocity time graph for decreasing velocity. Velocity decreases while the velocity is decreasing. Speed of the vehicle is reducing, but the vehicle is moving forward, no? Distance will be covered, but the amount it is covered will be less, so it will be like this side curve. If you know the curve direction, that is enough. You don't need to plot one by one the values and get it. If you know towards which side the curve is, that is enough. So I hope you all are clear. The ones who are not coming to my theory classes, the ones who have not watched my YouTube recordings, quickly take a screenshot. You all can later nicely, clearly write it. Okay, let's move on. So see, this part of distance time graph, it is increasing, no? That means constant velocity. If you take a velocity time graph corresponding to it, wait, I will draw it. Give me a minute. Velocity time graph corresponding to it. Velocity time. Okay, now we'll draw the graph. So these two parts both are increasing velocity. Sorry, distance is increasing. Okay, that is constant velocity situation. But look at this slope and this slope. I'll say this is A slope and B slope. If I keep a ball, okay, this is maths. I'm trying to find the gradient. Whose gradient is more? A or B? I think maths teachers would have told you, no, easy method to find the gradient. Like to compare two gradients, they say keep a ball here. Which ball will, move faster according to the slope? B ball will move faster, no? So B gradient is greater. If the B gradient is greater, that means the velocity of B is greater. So the velocity of A situation is lesser than B situation. So velocity time graph will be like this. Then here put a flat. Is there any gradient? No gradient, zero gradient. If I keep a ball, it will stay like that. That means velocity is 0. This is the graph. This is a hard question. If you all can understand this, superb. You all can understand this, and if you all can get this answer, superb. That means you all know this lesson clearly. Or else you'll have to do more and more questions and try to get the pattern. So the answer is answer number 3. Then the next one, a car which was traveling at a speed of 5 ms minus 1 was accelerated to 25 ms minus 1 within a period of 2 minutes. Find the acceleration of the car. So you might think, this is an easy question. I don't know whether there is an answer for this. We'll see. So why answer 2 is not right? Wait, give me 1 minute. Why answer 2 is not right? Because in answer 2, Putha, now I told you this is A situation, B situation, and C situation. No? A situation speed is greater than B situation. That can't happen, no? Now if I say this is 30, this is like 20, and this is 0. So here B's gradient is greater. If the B's gradient is greater, that means velocity is greater. So B part should be higher, A part should be lower. So here A part, B part, and C part is 0. This is a perfect answer. I hope you all are clear about. So here we can use the equation, acceleration equation, A equals V minus U over T. Final velocity 25, initial velocity 5. So acceleration equals 25 minus 5 divided by time taken. I can't just put 2 because I cannot use minutes in physics. I have to use seconds. So 20 into 60 to convert to seconds. Sorry, 20 divided 2 into 60. 2 into 60. So 25 minus 5 is 20 over 60 into 2 is 120. 0, 0 will get cut. 1 over 6 is the answer. So here we have a good answer, 1 over 6 ms minus 2. Because it is acceleration, final unit will be ms minus 2. Are you clear about this? Any doubts, any problems? Okay, let's move on to the 7th one. A fruit of mass 2 kilogram fell to the ground within 5 seconds after it detached from the branch. Find the height of the plant. So I think you all can do the question without any graph, any equation, again, any long equation. What is our latest equation? This is drop, no? Detached from the branch and fell. That means automatically it is falling. So we can use our short method. H equals 5t squared. Height in MA 5t squared. 5 is 5. T in this situation, T is also 5 seconds, no? 5 squared is 25. 25 into 5 is 125. Got the answer. Or else you all can go to the graph method. That is the second best method I would recommend. In that you have a little bit of a work. You have to find the final velocity. V equals U plus AT. Final velocity equals initial velocity plus acceleration into the time. Time is 5 seconds. 5 into 10 is 50. So you plot it like this. 50, 5, and this is the graph. When you find the area under the graph, you will find the height of the plant. To find the area under the graph, you have to see the shape. This is a triangle shape. Half into base into height. Half into base is from here to here. 5. Height is from here to here. Into 50. Finally, you will get the answer 125 meters. I hope you all are clear about it. Okay, let's move on. So is 2 kilograms not important? No, here there is nothing like that. Just to confuse you all, they have given. Okay, in case if they ask, what is the maximum momentum? Maximum momentum will be during maximum velocity, no? What is the equation? P equals m into v. Now 2 kilograms will be useful. 2 into final velocity was 50, no? 100 kg ms minus 1. That is the momentum, maximum momentum of this object when touching the ground. Okay, so some data they will give, like in a structured essay question, and later they will modify the question. Because they will ask the distance, after that they might ask you the final velocity, then they might ask you momentum, and when you study second term, third term, they can ask you what is the kinetic energy, potential energy, like that. They can ask you a lot of things. So when finding deceleration, it's ms2 or ms minus 2. It's ms minus 2, Buddha. Whether it is acceleration or deceleration, there the unit doesn't change. Okay, unit doesn't change. Whether it is acceleration, whether it is deceleration, ms minus 2 is a fixed one. Okay, hurry. Eighth question. Find the velocity of the fruit when touching the ground in the above question. And we just did that and came, no? We used the equation v equals u plus at. From where did we get this equation? Acceleration equation. A equals v minus u over t. From that we derive this. So v equals initial velocity 0. Acceleration, because it's a falling down object, acceleration will be gravitational acceleration. So 10 into time taken in the question, they had said 5, no? So velocity is 50 ms minus 1. I hope it's clear to all of you. Fine. Now see, yeah, all what we did again, they're asking, no? I didn't notice that. Find the momentum of the momentum and kinetic energy. Still, you all don't know the method to find the kinetic energy of the fruit when reaching the ground. Okay, momentum you know to find. Okay, P equals mv. Kinetic energy, I'll just give you the equation. Kinetic energy equals half m v squared. This equation will be introduced to you in the third term. In third term only we have potential energy, kinetic energy, work energy, power. There is a 18th lesson. So in that you will be studying about. So momentum equals mv. Mass of the object was 2 kilogram. Velocity was 50. So 100 kg ms minus 1. So here 50, 200, 10, here 100. So even if you don't know the kinetic energy equation, you can get the correct answer here because there is only the 100 kg ms minus 1, only one answer, one response is having it. So therefore, directly you can go for the answer. Anyways, for our curiosity, we'll try this and see. Half mv square to find the kinetic energy. Half is half, so you put the half. What is m? Even though it is a third term equation, now you can do it. M is mass. Mass is 2 kilogram. And already we found velocity as 50, 50 squared. This 2 and this 2 will get cut. 50 into 50 is 2500 joules. Yes, here you can see 2500 joules. So we have double confirmed and it's the correct answer. Yeah, there is a question. Sir, can you show how to find the velocity of an object thrown up? In our O-level syllabus, they won't ask you to find the velocity of the object thrown up, because now let's say you are throwing the object with 100 ms minus 1. 100 ms minus 1. What will happen to that object? It will become 90, 80, 70, 60, 50, 40, 30, 20, 10, and 0. So when it reaches the maximum height, what is the final velocity? 0. Okay. So whatever object which is thrown up, when it goes up, after some time, velocity becomes 0, and then it starts returning down. Then velocity increases 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It reaches back to the hand in the speed which you threw it up. 10th question. Which of the following graph represents the acceleration time graph of the above motion of the fruit? Now, Putha, you might think, sir, this acceleration time graph is not there in the syllabus. How dare you give this question, that, and this? But simply, without getting angry, sit and think. Object is falling down, right? Okay. The acceleration acting on this object or the fruit is gravitational acceleration. When starting time also gravity is 10 ms minus 2. Ending situation also gravity is 10 ms minus 2. Gravitational acceleration doesn't change, right? So only possible acceleration time graph in our syllabus is just a straight line graph. So why worry for this simple thing? Fighting that this is not there in the syllabus and that and this. Okay. How many things which are not there in the syllabus textbook have been asked in the past papers? Even curve graphs. School teachers are arguing that that is not there in the syllabus. But past paper questions are there. Here they are telling you to draw the acceleration time graph, not the deceleration time graph for acceleration situation. They are telling you to draw the acceleration time graph for the acceleration time situation itself. I hope you all are clear. Then there's a small structured essay question. Why initial velocity is also 10 meters per second? Which question, Buddha? This is not initial velocity. Initial velocity will be 0. Gravity is only 10 ms minus 2. Due to gravity, only velocity increases. Due to gravity. Because in schools, they have not clearly explained to the student that velocity is different from acceleration. Some students think acceleration and velocity are same thing. No, two different things. Due to acceleration only, this velocity increases. Due to deceleration, velocity decreases. So velocity is controlled by acceleration or deceleration. Either it is an increasing velocity acceleration situation or decreasing velocity, which is deceleration situation. Or no acceleration, constant velocity situation. Yeah, the ones who don't know about the graphs, please go and watch the YouTube recording. Clearly, I have explained to you. So before your term test, watch it. It will be really helpful. Give short answers for the following question. The friction graph related to a box being pushed in a rough surface is given below. There is a box in a rough surface. Initially, you are trying to push it, but that box is not moving because between the box and the surface, there is a friction. Okay. For a like, I'm just giving you all a value. Let's say that is 20 Newton is the maximum friction. We call it limiting friction. So, Buddha, if I put, let's say 5 Newtons, the object will not move because friction also will be 5 Newtons. If I increase it to 10 Newton, if I increase the force to 10 Newton, friction also will become 10 Newtons. It's a self-adjusting force. Like that, it can go until 20. Until 20 Newton, it can self-adjust. But if I put a force which is greater than 20, only then the object will move. So for example, let's say I'm putting 30 Newton force. Then what will happen? I'm putting 30 Newton. Friction is maximum 20. So to cancel the friction, out of this 30, 20 Newton will be used, and the remaining 10 only will be used to push the object. I'll do some questions related to it. For now, I just want to explain. So how much ever you put the force in this situation, no use until this maximum friction point, the object will not move. Because the object is not moving throughout this, we call it as static friction. Then this situation, object is moving, object is being pushed. Because the object is moving, we call it dynamic friction. The point between the static friction and the dynamic friction, the maximum friction point between the static and dynamic friction is known as limiting friction. I think our first question is what is A, what is B, and what is C? A is static friction, B is limiting friction, C is dynamic friction. I hope you all are clear about it. Name the parts A, B, C of the above friction graph. Yes, we know it, we have done it. Then what can be done in order to reduce the value of B? B is limiting friction, right? How can we increase the limiting friction? Limiting friction depends on the weight of the object and the nature of the surface of the object. If the weight is less, limiting friction will be less. If the weight is more, limiting friction is more. So normally we use two words. One is weight of the object or normal reaction of object. These two are same thing. Huh? The other factor which affects the limiting friction is nature of the surface. If the two surfaces are too rough, friction will be higher. If the surfaces are smooth, polished, limiting friction will be less. So in order to reduce the friction value B, that means in order to reduce the friction, smoothen the surface, polish the surface, lubricate the surface, apply oil to the surface. All that can be said. Okay, Putta, don't worry. I will finish the class early today, little bit early because of the term test. Then you all can do the prayer. So in the middle, I am not giving a break. Write to common methods of reducing friction in our day-to-day life. So very simple, Mebalanna. Application of lubricant, smoothing of surface, applying powder. This can be solid lubricant. So graphite powder, boric powder. When playing carom, we are applying powder, right? So all those are solid lubricants. Yeah, my WhatsApp number is there here in the. Okay, I'll write it again. Yeah. So you all can send your name, grade, school. The ones who are not there in the group, I will add you to the group. Then the last one, write to common methods of increasing friction in a day-to-day life, increasing the weight of the object, roughening the surface, making the surface rough, putting grooves and creases. Again, in the soles of the shoe, in the sole of the shoe, in the sole of the shoe, you can see lines, no? In the slippers, shoes, not only for design purpose, prevent slipping to increase the rusting. In the vehicle tires, you can see grooves like this. Okay, all those are to increase the friction. Using rubber grips, yes, that is also correct. In the bat, cricket bat and all, in the uh, grip, you don't keep the wooden piece. You put a rubber grip. Even in the bike, the racing part, there is a rubber grip. No, even if you take some of the pens which we write, okay, good quality pens, what do they have? They have a rubber grip. All that to prevent slipping, that is to increase the rusting. If you increase the rusting, no, increase the friction. If the friction increases, slipping will not be there. Vehicle tires and all those things. So I think there is a essay type of question. Okay, please do this. Next week we'll start the. Next week we'll be having the paper class. Hereafter, first week and third week of every month. Second week and fourth week will be a holiday. I will be sending the paper in the second week itself. Third week's paper will be sent on second week. Next, first week's paper will be sent on fourth week. So second week and fourth week, you can do the paper. First week and third week, we can do the discussion. So for grade 10, twice a month paper class is enough. Once you come to grade 11, every week will be paper class. So that's a different story. But now we'll go like this. Okay, if we need, we'll little bit increase the timing if needed. Theory class also properly we are going, and last week we have done the revision, and next week we are starting second term. The ones who are not coming to my theory classes, just for your information, we are starting second term lessons next Sunday. If anyone wants any further details about theory classes, what are we doing, what is our plan, please inform me. Please send me a WhatsApp message. I'll be happy to reply to you. Yeah, if anyone wants the recordings, previous recordings, if you are unable to join the classes, you send me a WhatsApp message. I will tell you how to get the recording, for how many days it will be available, all that details. I'll give it to you. So personally send me a WhatsApp message. So all the best for the ones who are doing the exams tomorrow and this week. So try to score good marks. We have the students who come to my theory classes, we have completely completed it. A detailed explanation. Okay. Today I got a school paper. Compared to the theory which I have taught the students, that paper is like a grade 9 baby paper. Okay, so whatever, even the hard things which you have taught in that paper, it's not there. So they have given the easy things. So when we learn the hard way, the hard thing, like easy papers are very, very easy. I think that my students would have done the paper early and slept also for the remaining time. So let's practice in such a way that finally one day, okay, finally one day, O-level paper will also become a very easy paper. Okay, so that you do the O-level paper and sleep for 5-10 minutes after completing it in your exams. We'll make it to that level, inshallah. If you properly follow the classes, if you properly do the papers, okay, if you like adhere to my advices properly, science subject will not be a burden. So all the best. Assalamu alaikum. We will meet in our upcoming theory classes. Next Sunday, very important, second term starting. Inform your friends also. New tudes also will be given.